Hello. Now next article from chapter 15, structure of atom, and it is radius of Bohr's orbit. So radius of Bohr's orbit. Now pay attention, or we can write here radius of orbit basically. Now I consider here electron is revolving, electron having a mass m is revolving around the nucleus with the radius r. So we consider electron is revolving. I consider here the simplest atom hydrogen, and then we derive this derivation. So for hydrogen, you remember, for hydrogen Z is equal to 1. So I consider hydrogen, and then by Bohr's first postulate. So first postulate is centripetal force is equal to electrostatic force. Now here we can cancel the common term. This r and 1r from r square get cancelled. So we get mv square is equal to, I write e square into 1, e square divided by 4 pi epsilon 0 r. Now here I can write v square by transferring m to this side. Hence v square is equal to e square divided by 4 pi epsilon 0 m into r, equation number 1. Now this is velocity square by Bohr's first postulate. Similar manner we can use Bohr's second postulate and we obtain v square. Also by Bohr's second postulate. Second postulate is angular momentum mrv is equal to integral multiple of h upon 2 pi. Now I can write a formula of v by using that. I can write it here. So I can write v. So v is equal to, I can transfer m and r to that side. So we get n h upon 2 pi mr. Equation, no, I can square this equation and then give the equation number. Squaring both sides, we get v square is equal to n square h square divided by 2 square is 4 pi square m square r square, equation number 2. Now see the equation 1, this is equation 1 and this is equation 2. Both the equations are equation of v square. Means here we can say that their left hand side is same. So right hand side is obviously same. Or we can equate equation 1 and 2. Hence equating equation 1 and 2. Now after equating, what we get? Now see here this, or I write it this one first, e square divided by 4 pi epsilon 0 mr is equal to this n square h square divided by 4 pi square m square r square. Now after that we have to cancel the common term. So common is here 4 pi and 1 pi only from this pi square get cancelled. This m and 1 m from m square get cancelled. This r and 1 r get cancelled. So here e square divided by epsilon 0 is equal to n square h square divided by pi m r. Pi m and r. ठीक है. We have to write formula for radius because heading be given radius of the orbit. So radius, this r we shift to this side, e square and epsilon 0 to that side. So I can write r is equal to, so we get here n square h square and this epsilon 0 here divided to that side multiplied. So epsilon 0 n square h square divided by this pi m and this e square to this side is divided here. So e square. And this is expression for radius of Bohr's orbit. Now here in this formula we can write here r is equal to epsilon 0 h square divided by, I am writing epsilon 0 h square divided by pi m e square. pi m e square into this n square. So I can consider this epsilon 0. The value is fixed, means it is a constant. H is a Planck's constant, its value is also fixed. Epsilon 0 value 8.85 into 10 raised to minus 12. H is 6.63 into 10 raised to minus 34 joule second. Pi 3.14. Mass of electron 9.1 into 10 raised to minus 31. E charge on electron 1.6 into 10 raised to minus 19. Everything is constant in this bracket having a fixed value. If I substitute everything, or means this is the constant I write here. So I can write here constant multiplied by n square. So we get this formula. Or we can write here R proportional to n square. So R proportional to n square. So R is the radius of Bohr's orbit, proportional to n means principal quantum number or number of orbit, obviously, n square. So we can write the conclusion. Therefore, radius of Bohr's orbit is directly proportional to square of principal quantum number. Question may be asked in examination, obtain expression for radius, you have to write up to this. May be asked, show that radius of Bohr's orbit is directly proportional to square of principal quantum number. You have to write up to this. Also, by substituting all constant, we write, if I substitute constant means epsilon 0, h, pi, m, e square, everything if we substitute, then we can write this value is R is equal to, it is coming 0.53 into this n square. So this value is in angstrom unit. Okay, this is in angstrom. Or we can write like this way also, angstrom. Therefore, radius of Bohr's orbit, for Bohr's orbit n is 1. N is 1. So if I substitute n is 1 for Bohr's orbit, n is 1. Hence R is equal to 0.53 angstrom. So this is a radius of Bohr's orbit. Listen, in examination, if the question is asked, they ask find out what is the radius of third orbit. So you can use this relation. First orbit having a radius is 1. Third orbit radius is n. You have to substitute 3. 3 square is 9. 9 times of this one is the radius of third orbit. Similar manner, you can find out radius of any orbit by using this formula. I hope everyone understood this. So this is very important article. Radius of Bohr's orbit.